go ahead to say we go ahead to say we define the function. What does the function say? The function say is valid. It says row integer column int. So basically it takes in a row and a column, right? The integers of the row and the column, and it checks to check the cell is to check that the cell is within reach. Okay, so what do we mean by that? So we take row is in the maze. We check is to check whether it's within the maze, right? Whether it's within the four corners of the maze. What do I mean by that? Basically, whether it's within this place. If it is something that goes out of here, we are not going to work with it. Basically, just as I explained earlier, let's say we are standing here, right, and we receive a left movement. I want to check if a left movement is valid, right? If we check a left movement, it's going to be out of bound, so we won't work with it. So how do we do that? We say 0 less than row count, right? So basically, what are we saying? We're saying, say if this thing is within the range of 0 to the row count. Our row count for this example, if you are making use of this visual representation here, is going to be 3, right? Because we only have 3 rows, 1 2 3. So if we have something that is going to give us a fourth row, then we are going to say, nah, that's not within our space. So row, we check the range, and we also check the range for column as well. It's also going to be 3. If it gives us anything outside, we run. So we confirm it this way. We check it, see if this or this can return false. So we now say check if the cell is a wall. So if it returns, if the coordinates of the row and the column returns a 1, then it's going to be a wall. So return false. Check if the cell has been visited. So we check our visited column, visited set. So I think somewhere here we instantiated it. So I think I didn't speak about it. This place, the place, uh, the place we have visited, or places we have visited, more like our builder object. So okay, so path holder. I don't think this is correct. Just the places we have visited. So the places we have visited. So this holds the path or the coordinates of the places we have visited. And yeah, that's what it does. So that whenever we visited a place and we come there to come and check, oh, have we visited this place before? It returns us telling us, oh, this place has been visited. So if it has been visited, then we return false and tell that guy to go and do something else. Now, if it survives all these guys, we shout to it, Yakubu manage, you survive, right? And then we return true, basically. Now that's it for it's valid. So we can close that out, and then we call our backtracking. What do we do in our backtracking? We say we start by applying is valid function to know if this rule works or not, right? So from the first rule we say if not is valid, so we check if it's 1 or is outside of bound or whatever, right? We check it, and if it is false we bounce it. But if it's not, it goes down to be appended into our path and into our is visited or visited what's it called visited set, right? And if this is our specified end axis or coordinate, so we check if it's our end row and column. So if you look here, when we came in here, we passed in an end tuple. So this is the place we are trying to go to. This is the place we are starting from, and this is the place we are going to, right? Sorry about that. Now, because of this, so if we get to the place we are going to, what do? We stop and record as true and stop the whole process. But then we go again, we say now here the crispy part, so basically where we start doing the real business. We now try every direction relative to our present location to see if any is valid, not visited, not out of bound, not a wall. So we iterate the 4 locations round and around the point for validity. So what do? We say for row direction, column direction, in directions. So we are going to loop through it through all the directions, and we say next row is going to be the row plus the row direction. So we are adding to the left, moving up or moving left and right, right? So what do? We say row plus row direction and column plus column direction. What do? So you know those are tuples, right? So we are just extracting the row bit, the column bit, right? And then we are just going to take that in and go up. We're going to make our direction be up, down, or left and right. All of them will be tested, and for every one of them we test, we say if they're backtracking. So we call the next row and the next column, and it's going to go through this whole process again of checking if it's valid by going through and checking if it's out of bound and whatever, right? And any of them that is valid, it goes through and returns true. Any of them that is not valid, we will see what happens. It says if it's a false, if false is returned, then we pop the location out from our path, right? And then go ahead to return false of that direction, and then go on to consider other directions. Okay, other directions, and consider this one as the dead end. So basically we consider it as a dead end, and that there is nothing to look for in this direction. Basically we go towards another direction, we pop it from our path and pop it from our visited and return false on that one, right? And basically take us back to it to check other directions, and we go from there. Now what else do we do? We also go ahead to now say here we extract from the start row and the start column from the start tuple added in line 8. So basically we will see here, let's close this backtracking. I delete. Now we are done with the backtracking process. Now we are talking about how to instantiate this stuff and make use of it, make use of the backtracking. Now we say start row and start column. So with what we brought in was a tuple of in integer start and an integer of the row, integer of the column. So basically what we're trying to do here is to extract it, to bring out the row and bring out the start column, so that we can then because what our backtracking accepts are integers. It doesn't affect the tuple as it is, right? So we put it in as an integer, and then finally we return the path built as the latter at the latter end. So basically whatever the path has built and has appended into this guy, and has gotten to the end of the what's it called, of the end basically coordinate. So we append that to the path, and at the end we are golden and good to go. So yeah, that's it. Then we go ahead to print maze runner, and it will return the value, return the path, and we will see the value. So when we run that, let me see, sorry, path is not defined. Let's see why. Okay. 02. So path is not defined because our third index is this guy, index of 0, index of 2, and we are trying to go to 2 comma 2. 2 comma 2 is this guy now. So we see that, okay, let's see what it said. Path not defined is not defined before. Wait a minute, who are you? I don't know why it said path was not defined. But obviously here it is giving us the correct result, or the correct return, where we have 0, 2, and we go down that line 1, 2, and 2, 2, 2. Basically we just go down a straight line and we get to our line, our distance. I think if we want to try something else as well, we could also try 1 here and return, and we'll see here that we go from 0, 1 to 1, 1 to this. And so basically you see how it goes down the distance. So that's it for maze problem. And yeah, so see you on the next one. Muchas gracias. Auf Wiedersehen. Tschüss.